Hello again. We are finishing our discussion on linear equations for now by talking about weighted averages. All right, so let's define a few things again. We'll need to do this. The weighted average is just multiplying each value in a set by its weight and finding the average of that. So basically what it says. Mixture problems are one of the applications of this. So they are problems in which two or more parts are combined into a whole thing. And then uniform motion problems are where someone is moving at a constant speed and we're trying to figure out either the distance or the time that it takes to get wherever they're going. So here's a mixture problem example. We have two coffee companies. Canuck Coffee costs $12 a pound and Lone Star Coffee costs $7 a pound. So how many pounds of Canuck Coffee should I combine with 6 pounds of Lone Star Coffee to make a mixture that would cost $8.50 a pound? So we set it up with a table, and so we're going to talk about the brand just to keep it straight in our minds. We're going to talk about how many pounds of each we're going to use, the cost per pound, and the total cost. Okay, so if I look at Canuck Coffee, I don't know how many pounds of Canuck Coffee to add to this mixture, so I'm going to use X to represent that. I do know that it costs $12 per pound, so the total cost is going to be 12 per pound times the X pounds, or 12X. So the total cost of Canuck Coffee is 12 times X. Then I have Lone Star Coffee. I know I'm going to have to add 6 pounds of that. The cost per pound is $7 per pound, and so the total cost would be the 6 pounds times the $7 per pound, and that's $42. So the mix is going to have the X pounds of Canuck Coffee and the 6 pounds of Lone Star Coffee in it. So that's a total weight of X plus 6. I want the cost per pound to be $8.50. I was told that. And so the total cost is going to be the number of pounds, X plus 6, times the cost per pound, $8.50, just like it was when we were talking about each individual brand. So I'm just multiplying across each row to get to that last column. So now I'm going to add the total costs together, and that's going to be my equation. 12x plus 42 is going to equal $8.50 times x plus 6. So this is an equation that has lots of things that we've already discussed in this chapter. Let's get to solving it. The first thing I need to do is get rid of those parentheses. So $8.50 needs to be multiplied by the x and by the 6. And if I do that, I get $8.50 times x plus 51. All right. Let's see, so I need to get my x's on one side. I have x's on both sides. So that means I will add negative $8.50 x to both sides, and that will give me $3.50 times x plus 42 equals 51. Add negative 42 to both sides just so that the x's are by themselves, and that will give me $3.50 times x equals 9. Okay, and since x is multiplied by 350, I need to divide by 350 on both sides, and that will get me an x value of 9 over 3.5, which doesn't make sense, but $2.57 does. So I should add about $2.57, 2.57 pounds of Canuck Coffee. Remember what x represents. X represents the pounds of Canuck Coffee I'm adding. All right, so we have another mixture problem. I have 100 milliliters of a 20% antifreeze mix, which means the other 80% is water. So I want to know how much should be poured out and replaced with pure antifreeze to make it a 45% antifreeze mix. So I've got the antifreeze mix, I've got the volume, I'm talking about the percent antifreeze, and then I'm going to talk about the actual volume of it that is made up of antifreeze. So in the original, I've got 100 milliliters, 20% of it is antifreeze, which means that 20 milliliters is antifreeze. I multiply the volume times the percent antifreeze, and I get 20. So if I were to pour out a certain amount of it, which I'm calling X, I'm actually thinking of it as adding negative X milliliters to the mix. It's also 20% because I haven't done anything to it. So the volume of the antifreeze that I'm pouring out is 20%, 0.20, times X, and that is all negative because I'm pouring it out. Now I'm adding pure antifreeze to the mix. So the volume is the same as the volume that I poured out, but it's now positive. The percent antifreeze is 100%. So everything that was part of the volume of the mix is part of the volume of the antifreeze. So I'm adding X liters of antifreeze. So the new is now going to be back up to 100 milliliters. The percent antifreeze, I want that to be 45%, which means that the volume is 45. because 45% of 100 is 45. Again, I add the last column together and make an equation out of that. So I have 20 minus 0.2x plus x equals 45. Okay, so there's my equation written out. I'm going to combine the like terms that are on the left. I've got negative 0.2x plus that x. So that combines to give 0.8x. So I've got 20 plus 0.8x equals 45. Add negative 20 to both sides. The 20s will cancel, and I've got 0.8x equals 25. Divide both sides by 0.8, and that will give me an x value of 25 divided by 0.8, which is 31.25. So that tells me exactly how many milliliters of pure antifreeze I should add on after I pour out that same amount of the mix that I was starting with. Okay, now let's talk about some vehicle problems. First, a one vehicle problem. We have Suzanne riding her bicycle uphill for 50 minutes and she's covering 3 miles. Then she travels downhill on the way back and it only takes her 40 minutes. What is her average speed? So the total distance is 3 miles up and 3 miles down for a total of 6 miles. The total time is 50 minutes going up and 40 minutes going down, so that's a total of 1.5 hours. Average speed would be total distance divided by total time, which is 6 divided by 1.5. That's an average speed of 4. So her average speed is 4 miles per hour. Now she's beginning her journey back. She is traveling at 5 miles an hour. At the same time, Ian is cycling towards her at 3.5 miles per hour. So after how many minutes will they meet? Distance is rate times time. That's a physics equation. So they are both traveling for an unknown time, t. That's what we're actually trying to figure out, the amount of time after which they will meet. Suzanne's distance is her rate, which is 5, times her time, which is t. Ian's distance is his rate, 3.5, times the same time, t. The total distance that has to be traveled is the distance that is between them, which is 3 miles, as we learned about that on the previous slide. Okay, so those two, 5t and 3.5t, have to add up to 3. And so we collect like terms. We get 5t plus 3.5t is 8.5t. The 3 stays a 3. It's a one-step equation, so I will divide by whatever t is being multiplied by, which is 8.5. I do that, the 8.5s cancel, and so t is equal to 3 divided by 8.5. And that works out to, on a calculator, 0.353 hours, which doesn't make a whole lot of sense. So multiply by 60 to convert that to minutes, and you get 21 minutes. So they are going to meet in 21 minutes. So that's pretty much everything I can give you as far as a weighted average problem goes. We will talk about this more, but if you have any questions, let me know, and I will see you tomorrow.